bear with us. Okay, so with let's look at this code. It says express the relation below as a set of ordered pairs. So if if you're going to express this in ordered pair and say fill in the blank, 15 goes to 2, 12 goes to 6, and 4 goes to 16, right? So if you have something like that, then that's okay. So let's all right. So if you have express the relation below as a set of ordered pairs. So if you're gonna fill in the blank, of course. Um, if you want to express this as a set of ordered pairs, then you're gonna give so on the y axis you have 6, right? So on the x axis you have 0. Okay, so if you have 6, then I think this is 0. If you have if on the x axis, so on the y, we really don't have a point there, but anyway, if you have on the x axis, if you have 1, then on the y axis is 5. So you'd have 5 right there. Well, no, that's 0. So right here you'd have 5. And then if you have 5 on the x-axis, if you have 5 on the x-axis, 1 second. Let's make sure we get this. So there are three points, and let's see, fill in the blank. 6, 6. When you have a set of coordinates, okay? When you have a set of coordinates, it is x and y coordinate, and it will give you a point. So when you have a graph, you have to give the x coordinate and the y coordinate, because the graph have an x-axis and a y-axis. So if these are your so these are the coordinates. This is the x and this is the y. So a x of 17 correspond to a y of 9, and they will tell you that. Okay, 11 correspond to 20, and 16 with 14. These are coordinates. It's going to allow you to find a point on the graph that, or a position on the graph where you can put a point. So, okay. So if you're given points like this on a graph, each of these points, you can use a coordinate to define the point. First, you have to put the x, how much x, and how much y. So the x comes first, and then the y comes after. Okay? So for this point, the x would be 1 and the y would be 0. So the domain is 1 and then the y is 0. for this point, for this one, all right, there's one with there's a point in between. All right, so this point, so for this point right here, this point right here is defined by x3 and y10, because if you on the x-axis, if you go up 3 and you come across 10, it intersects right here and you get a point. So this point is defined by x3, y10, okay? Domain and range. So it's the same thing. The domain is on the x-axis and the range is on the y-axis. So it just coordinates that allow you to identify points. All right, so we said that one did correspond. Let's look again. So they said which mapping diagram represents this relation. So we know that x0 x1 y0. So 1 0, that's correct. And we also know x3. So x3. So this is the domain x. So this is 1 2 3. This point is 310. So we're gonna look to see which one is 310. This has 30. This has 310. So this is definitely incorrect. So the correct one that represent this relationship is this one. Okay, and you can write the coordinate for each of these points. So the domain will be 1 2 3 4 5. So this will be 5 10. This one would be 5 7. Okay, so basically you're going to put the domain, which is the x coordinate, and then the y coordinate comes after. Okay, so that's basically what's that's testing. So coordinates, if they give you a coordinate, they're going to give you the x value first and then the y value after, the domain and range. So let's do this one. So okay, for this point, where x is 1 and y is 6. All right. Okay, but they ask you to fill in the blank. If x is 1, the domain is 1, and that if you go straight up, this point is y6. So this has to be 6. Okay? So again, the coordinate is the x and y. The first one is the x, the next one is 1. And the coordinate, just each point, you have to define each point as x and y. Like this point right here, the x value for this would be 10 and the y value is 0. Okay, x value 10, y value 0. So this is, so that's the x value and y value. So again, the x value and the y value for each of these points. So if you have an x value of 9 and there's a point, so x value of 9, let's see, x value of 9, so you're going to go straight up to find the y value, and this is the point is right there, so it corresponds to a y value of 9. So this would be 9. So each point you're going to define where it's located. Oh, sorry, we didn't finish. All right, so if you have, okay, all right, so we didn't finish, but this coordinate is represented by this. So if you have x8 and you come straight up, the point is on y8. So x8, y8 defines this point. And then for this point, it will be x4, y7. So each point can be defined by x value and a y value. Okay? So All right, so all right, let's so for this point, let's find out what they're asking us for. Fill in the blank. So x value of 9, y value 0. You can see that. For x value 1, you come straight up and the y value is 9. So x1, y9. So there is an x value which is missing, but the y value is 2. Y value is 2, you come straight across. The point is right here. So it corresponds to an x value of 5. So it's an x value of 5. All right, and then x value is 6. Okay, x value is 6, and you go straight up to find the y value, and the y value is 4. So 4. Okay, so the domain and range. So once you understand this concept, then you can plot your points, and you can get a graph out of it. Okay, all right. So so you say that express the relation below as a graph. So you're going to express this relation as a graph. So x0, y5, x2, y2, x5, y8. So these are points on the graph, okay? So these are points in the graph. And then in order, okay, so we have 0, 5, we have 2, 2. Where's 2, 2? 2, 2 is right here. Okay, so if you were to draw a graph like this, then you'd come straight down collecting these points and then go up to collect those points. Okay, but this point is right there. All right, so once you're given the coordinates, you can plot the points. Once you're given the coordinates, okay, so look at this set of ordered pairs: minus 11, 0, 15, 1, 0, 0, 15, minus 14. Which mapping represents this relationship? So, you just have to look. 11, minus 11, 0, that's correct. 15, 1, 15, 1, 0, 0, that. And 15 minus 14, this 15 is going there, so 15 going, sorry, this one. So this one is correct. So in order to plot a graph, you have to know the coordinates. You have to know the coordinates. So you're going to be given a x value and a y value. Okay. All right. So for this coordinate, check the plot on the graph. Check the plot points on the graph. Some of the points have already been plotted. So so this minus 5 is going to minus 4. So minus 5 is down here. All right, so the x is minus 5 and the y value is minus 4. So x value of minus 5. So over here is positive and over here is negative. So minus 5 is on this line, and then minus 1, and then so on top is the x value, on top the y value is positive, and below the y value is negative. So your minus 5 coordinate will be right there, and it corresponds to a minus 4 y coordinate. So you're going to have that point there. Okay. Now the next one is minus 1 and plus 10. So minus 1 is your x coordinate, minus 1 and plus 10. That is already there. Then you have 2 and minus 6. So your x value is 2, positive 2, and minus 6. So that coordinate is already there. The next one is 3 and 2. So the x value is 3 and the y value is 2. So that coordinate is right there. So you're plotting the points on the graph using the x value and the y value. All right. So all right. So let's look at this one. Okay. Let's look at this. So write the numbers in the range with commas. So the first, when you have a point on a graph, you're going to have an X and a Y. The X is the domain and the Y is the range. So we have a series of points here. So it says write the numbers in the range with commas between them. So the only thing is which one is first. All right. It didn't say in order anyway. So, you can always say you move from right to left. So for this first point, what is the coordinates? It is 2, 4. So this range is 4, right? For this second point, the domain is 1, the range is 2. So that's 2. For this one, the domain is -2 and the range is 0. So this has a range of 0 right here. And then for this one here, it has a domain of -2 and a range of 1. All right, so what is the range? So the range is the first set of numbers and the domain is the second. So I think we fully, it's important to know what a function is. If each x value is paired with one y value. So let's look at this. So domain x, range y, 11, 10, good. 8, 12, good. 16, 12, sorry, 16, 2, good. 10, 13. Is each x value paired with one y value?
Yes, sir.
Right. So this relation is a function.
Each x value is paired with only one y value.
All right. So it's a function. All right. So look at this set of ordered pairs. Is this relation a function? So 8 minus 9, 6, 14, 6, 9. So for it to be a function, each x value have to be paired with different y values. So you have 2x value of 6 and it's paired with different y values. So this is not a function, right? Because each x
Yes, sir. It's not a function.
okay, it's not a function. Good. All right. So is this relation? So each x value has to be paired with just one y value. 7 is paired with 11 and 7 is paired with 0. So it's not, right? So what about this one? So each x value,
Right.
x value 1, this x value 1, this x value 1. So this is a function.
Yes.
Okay, good. All right, so each x value should pair with only one y value. So this one is paired, this x value is paired with 12 and 18, so it is not. So look at this, or is this relation a function? So 6 is paired with 18, 6 is paired with 13, so it's not a function. All right, so let's look at this. This x value of, say, 3 paired with this y value, 4 paired, 5 paired with that. So it is a function. Each x value is paired with only one y value. So it's a function. All right. So let's do this one and then we can move on, right? So which of these relations is a function? So we have 2x value there of that, and they pair with different y values. So this is not a function. We have 2x value, but they're paired with different y values. So this is a function. In this one, we have all different x values. This one, we have two similar x values, but they're paired with different y values. So the only one that is a function is each x value is paired with different y values. Each x value is paired with different y values. Sorry, each x value is paired with one y value. Each x value. So each x value paired with one y value. So this not a function. This not a function. This each x value is paired with one y value. So which one of the relations is a function?
Can I call it C?
C. Okay. So this one.
The darker blue?
Okay. All right. So let's look at this graph and determine. Remember the definition of a function. If you look at this, okay. So let's take this point for example. This point right there. It has two x values, right? Right. So if you come straight down from here, you're going to have, say this is plus 1. If you drop a line straight down from plus 1, it's going to have two different x values. Sorry, two different y values. What am I talking?
Yes, it's not a function.
So it's not a function. So
Yes.
it's not a function because it has each x value have two different y values. What about this one? Huh? Is this relation a function? Each x value have only, let's say, right?
No, it's not.
It's not?
So it's not a function.
Why?
Yes, it's not.
Why it's not a function? Each x value.
Because if we're going to call this one 1, each x value and each x and each y value are supposed to be different. So if we're going to call this 1,
No, so the definition is each x value must have only one y value. So if you plot a point and all along here, they're gonna have different x values. Okay. All the points are gonna have different x values. Right? All right, say for instance, this is 1, 2, 3, 4. X is 4, you come up, only one point going to define that. X is, say, 3, 1 point. So is it a function, yes or no?
I don't know.
So it is a function. Each x value have only one y value, right?
Okay.
All right, so let's look at this one. All right.
X value has only
So each x value should only have one y value. All right, let's take this x value. Say take x value
all right. I get it.
1. So this x value 1 gonna have a y value up here, because if you draw a straight line up, have a y value there, and then it's gonna also have a y value here. So it's gonna have more than one y value, right? Or if you take, say, 2, take x value 2, it's going to have a point there on the y-axis, and it's going to have a point down here. So is it? So it's not a function, right? So is this relation a function? So take x2. x2, you'll have a point right there, and you have a point down there. So it's not a function because each x value is going to have more than one y value, right? So,
Yes.
so
Mm-hmm.
write down the definition for a function because you need to look at it a million times and then million and one time you probably won't need it. So let's take this one. Look at this graph. Each x value should have only one y value. So let's take 2. You have a point there, you have a point there, different y values. So this is not a function, right? What about this? So x, so this is 1, 2, 3, 4. X of 4 have a y value down here, and it also a y value right there. So is that a function? Is that a function? Okay. So, so it is a function. So that one is a function. It's a you can use the vertical line on a graph to determine whether a relation is a function. Uh, if it's impossible to draw a vertical line that intersects a graph more than once, then each x value is paired exactly with one y value. So the relation is a function. Okay? Um, when we look at this, so the vertical line, because this, when you have an open thing there, that means it's probably greater than. Okay, so the open so an open circle indicates an excluded value. So when you have a so when you have an open when you have an open circle, it actually means greater than this value. Okay, so that's what an open circle mean? All right. So it's greater than this value. That's what the open. So you want to do a few more to further get the understanding.
Yes.
Yeah, all right, let's do a couple more. Yeah, so open circle means actually greater than the value that they give you. So I don't think we went over that, so that's what that means. All right, so look at this graph. So, so take this point for example. Take x of -1. So it has two y value because when you have a solid circle, it means including the number. So this will be 1 to whatever. So it's include this number, this include this number. So you have more than one y value. And then if you take this x value, it also have more than one. So this is not a function. All right. So again, this is not a function because you have more than one y value, right? And then similarly, this is, it's a solid circle. So you have more than one y value, for the for x. So x of 2 have two y values. So this is not a function. And again, we did a circle because in a circle, if you take say one can come up there and one can come down there. So you have two y values for the circle. So this is not a function. All right. So now this open means greater than. So it's not x is not 0 for this one because it's greater than. Let's come over here, and then when you take 1, 2, 3, 4, when you take an x value of -4, this is -4, but this is greater than -4. So it's not including -4. And then for this x value of 0, as we said, this is actually greater than 0. This is exactly 0. So each x value have one y value, right? So this is a function. Remember what the open means. It means so it actually means not including the number. So it's not include. So this is 1. It does not the x value for here, it would be less than, not including 1, less than 1, and for this one not including 1 but greater than 1. And then for this one, it means this is 4. It means this x value not including -4, greater than -4, however. And then for this one, it means less than -4. So, but this one though, look at this. Look at this. So x of 1, 2, 3, 4. So x4, there are two values for x4 and two different. Sorry, there's one x or there are 2 points on x4 with different y values. So this is not really a function because of this right here. So it's not a function, right? So let's look at this. So what is the x value of this point? One second, let's see. So it says plot the point in this graph with a y value of 7. So y value of 7, 7 is right there, and you come straight across to see where it intersects the graph. It intersects the graph right there, and that corresponds to an x value of what? What is the x value? So this point right here has an x value of 10, right? Correct?
Mm-hmm.
Right. So it
Yes, correct.
has an x value of 10. All right. So plot the 2 points and this function with y values of 2. So plot the 2 points on this function with a y value of 2. So y value of 2. So what you're going to do, you come across, it's going to intersect right there, and it's going to intersect right there again, right? So the x values would be 3 and 7. Do you see that?
Yes, sir.
Okay, so 3 and 7. You just come across to where it intersect the graph, and then you write. All right, so let's look at this one. Plot the points on this function with an x value of 4. X value of 4. So x value of 4 comes straight up. It corresponds to a y value of 6. The y value is 6. So what you're seeing that you can use the points to plot the graph, and then after you plot the graph, then you can use the graph to identify points that you didn't use to plot the graph. All right, so plot the point in this graph with a y value of 1. Sorry, x value of 1. So x value of 1, you come straight up and you get a y value. Come across and the y value is 7. So y value is 7. All right. So plot the point in this function with an x value of 4. X value of 4. So x value, so you come up. So it corresponds to a y value of 7. All right, let's look at this one. It's a plot the point on this function with a y value of -6. So y value of -6, say come below. This is the y-axis, x-axis, and then the graph is right there. So you come across, so where -6 intersect the graph, and intersect the graph of x4. So the x value is 4. All right. Plot the point in this function with a x value of -9. So the x value is -9. So you come across here, -9 is over here. You come up and see where it meets the graph. It meets the graph right there. And your y value is +7, right? So the y value is 7. Okay. So if they
Go over that. Go over that just now. Repeat
okay.
that.
All right. So when they say f function x is equal to 12x minus 4. This is they're actually giving you the coordinates for a graph. This is the equation for the graph. f function x is actually y, because y is now dependent on what's happening to x. As x increase or decrease, y is going to vary. So this is the equation for a graph. F function x is actually y. What you're accustomed to is y, the range. And then this is the, So if f function 5, now x is replaced by 5. So where you have x over here, you have to put 5. So f function 5 is 12 times 5, 60, minus 4, so that's 56. You follow that?
Yes, I
Because
get that just now. The
fx, the
confusion.
function, is dependent on what's happening over here. Fx is actually y, okay?
Mhm.
What you're accustomed to calling y.
Mhm.
So similarly, if you're going to write this equation, this is equation for a graph. Fx, which is y, you can just substitute and say y is equal to x plus 2. So whenever you change the value of x, you can get a point y, and you can plot the points on the graph. So if f6, so x is substituted with 6, so that would be 6 plus 2. f6 is equal to 6 plus 2, which is 8. And then this, again, this is the equation for a graph. Fx is y, which is equal to 9 minus x over 21. If the x value is 63, then you put your x value there, and this becomes 9 minus 63 over 21, which is 3. So it's 9 minus 3, which is 6. Okay? Again, so if you're going to use the function rule to find the f minus 8, okay? So fx, this is y, equal to 4 um, absolute value x plus 7. So it is equal to absolute value plus 7. So if x is minus 8, then you're going to get 4 times fx is equal to 4 times minus 8. 4 eighths is minus 32. Minus 32 plus 7 is equal to minus 25.
Yes, minus 25.
1 second. So we made a mistake. So it is actually okay, so it's an absolute value. They don't want you to, so when you have the absolute value, you don't use the sign. Okay? When you use the so when you see this double bracket, it means the absolute value. You do not use the sign. Even though it has a minus 8 there, you just use the straight 8. So 4 is 32 plus 7, that is 39. Okay? So it's the absolute value. All right. This one is straightforward. So fx, which is y equal to x over 6 plus 8. So x is 102. So 6 into 102 give you 17, right? 17. So x is 102. 6 over 102 divided by 6 is 17 plus 8. That's 25. 25. Okay. So did you, for this one, fx, which is y, is equal to x over 4 plus 5. Again, when you see something like this, it's a graph. What they could also ask you to represent this as a graph. So if you're going to represent this as a graph, you can give x any value. And once you get 2 points, and if it's a straight line, you'll get a straight line. So if x is 8, then 8 divided by 4, that is 2. plus 5, that is 7. All right, so again, so this is not going to be a straight line graph. Once you have, a square, it's not going to be a straight line, okay? But it's still a graph because you have y and you're going to plot y against some x value. So if x is 1, you put 1 there, okay? So that is 1 minus 11 is minus 10, right? Right? Minus 10 square is, did you get that? Did you follow that one? All right, so looking at it again.
1 minus 11 for minus 10.
All right, so let's look at this. So this is another graph. This is a linear graph. So y is equal to 5 minus x, or fx is equal to 5 minus x. So substituting minus 1 for x. So this would be minus 1, so it would be plus 1, right? So 5 plus 1 is 6.
Mm-hmm.
All right.
Plus 1 is 6.
All right. So again, function x is equal to that, which is y. Okay, this is on the y-axis, equal to x over 75 if fx, they say use the following function rule to find f75. So if x is 75, then function 75 is equal to right?
So you put another 10.
All right, good. So using the following function rule to find f30. So the function rule is fx equal to 60 over x minus 2. So f30, that means x is 30. So if you substitute it in this this formula right here, so it is 60 divided by 30, which is 2. 2 minus 2 is 0, right? Okay. So you want to find f minus 2. This is the function, the function rule. The function rule says that y is equal to 4x plus 11. fx is just y. The function of x is y. You're plotting y against some x value, but y is going to vary with x, and it varies with x like this. Okay, y is going to vary with x, but it's going to vary with x like this. Okay, so as x get larger, y going to get larger. So if x is minus 2, we substitute minus 2 here. So we get 4 times minus 2 is minus 8, plus 11, so that's plus 3. Okay, similarly, the function rule is fx equal to minus 136 divided by x. So y is going to vary with x. This is how it's going to vary with x. If x is 136, then you substitute it in the equation. So you're going to get minus 136 divided by 136 is going to minus 1.
0.
So you're getting the coordinates. This equation gives you the coordinates so you can plot the points on the graph to get the graph. That's basically what it's doing. So this fx is y. This fx is y. And you're plotting it. You're plotting y against x. But this y is going to vary with x with this relationship. So it is equal to 11, the square root of x plus 68. If x is 13, so f13, so that means x is 13. So it's going to be 13 plus 68. 13 plus 68 is
81.
the square root of 81 is
9.
okay. So it will be 9, but you have this 11 times the square root. So 11 times 9 is
99.
okay. So essentially, when you have a function allows you to make a graphical representation of whatever you want to do. But this function, this value we call y, is going to vary like this. It's going to vary with x in a specific manner. That is 3x plus 7 squared. So if x is 9, you just substitute. So f9, you substitute x for 9. So this would be 3 nines, 27, right? 27 plus 7, 27 plus 7, 34.
34.
34 square is?
What's the square of that? 1156.
So that's 1156.
Yes.